So welcome to the course CE22029, Design of Bridges. So myself, Dr. R. Satya, Associate Professor, Department of Civil Engineering, will be handling this course, Design of Bridges. So I'll be handling the first two units of this subject. So this course is designed to help you understand not only the theoretical principles behind the bridge engineering, but also the practical aspects of designing various bridge type. So by the end of this module, you will be able to analyze the loads, understand the various forces on the bridges, and design both the short span and the long span reinforced concrete bridges. So let's get into the subject. So coming to the objective of this course, the main objective of this course is to study the various forces acting on the bridges and to learn how to design different types of bridges. So from the unit 1 and 2, you will be able to analyze you will be able to first you will be able to design and analyze the short span reinforced concrete bridges. Secondly, you will be able to gain the skill to design long span RC bridges, including the continuous girders, box girders, balanced cantilever and the arch bridges. So let's see the syllabus of unit 1 and 2. So in unit 1, the short span RC bridges. So let's look at the course structure. In unit 1, we will focus on short span RC bridges. We will cover the various types of bridges and review the relevant loading standards. So you will learn how to choose the appropriate type of bridges, study the Indian road, the IRC specifications for road bridges, and go through the design process of RCC solid bridges. So you'll also be able to analyze and design the slab culverts, T-beam and the slab bridges. So the next, in unit 2, they should focus on the long span RC bridge design. Here we will dive into the design principles of continuous girder bridges, box girder bridges and balanced cantilever bridge, as well as arch bridges and box culverts. So you'll see that with the increased span, structural behavior becomes more complex and advanced design techniques are required. So the textbooks you can refer us for a deeper understanding of this course. You can use two textbooks: The Design of Bridges by Jagadish and Jairam, and Essentials of Bridge Engineering by Johnson Victor. So for further reading, there are several recommended references on Priestess Concrete and the Bridge Engineering, including works by Sinha and Roy, Ponusamy, Krishna Raju and Pandit and Gupta. So these books will help you to grasp both fundamental and the advanced concrete and bridge engineering. So these are the list of reference books. So we can just refer these books and have an idea of the different topics. So coming to the introduction of the bridges. So let's define a bridge. So the bridges or the structure designed to span physical obstructions such as rivers, valley, roads or railways, or to provide passage over the obstacles. So it is a structure that crosses natural or artificial obstacles such as river, valley, railways or roads to allow the safe passage of vehicles, peoples and utility. So coming to the main functions. So the main functions are carrying services like highway, railways or pipelines over the barriers. And the main another important point of the bridges, it transfers the load from the traffic and the transfers the loads from the traffic and the bridge itself safely to the safely down to the foundation and then to the ground. So a bridge is not just something that goes over something else. So it is carefully engineered solution meeting both the safety and the utility. So let's see about the development of the bridges. So the development of the bridges evolving from the simple logs and the stepping stone to the sophisticated structures using advanced materials like steel and the concrete. So if you see the earlier civilizations like the Sumerians, Egyptians and the Romans utilized the basic materials and the design, including the arches and the beams. So later, with the advancement in material science and engineering, bridges became larger, stronger and more complex, facilitating trade, transport and the infrastructure development. So if you see the detailed evolution of the bridges, so in early ages, that is in ancient civilizations, the primitive bridges, the earliest bridges were like natural formations like fallen trees or the stepping stones. So the ancient civilizations in Mesopotamia, Egypt and India used logs, planks and vines to create a simple crossing over the rivers and the streams. The Sumerians, Egyptians and the Romans mastered the arches, used it for both bridges and aqueducts. So the Roman stones arches in particular were known for their durability and longevity. So the Romans also utilized beam bridges often made up of wood or stones. So after the ancient period, coming to the medieval period, so the bridge building techniques in Europe saw a decline after the fall of the Roman Empire. So in Asia, one of the oldest surviving stone segmental arch bridges with open spandrels is still now existing in China. So the rope suspension bridges using twisted vines or were developed in remote parts of Asia and South America. So coming to the post-medieval period, after the Industrial Revolution brought the use of iron and steel in the bridge construction. So there are a lot of bridges were built using this iron and steel. So the iron bridge in Brookdale, England, built in 1779 was a landmark of structure using the cast iron. So after this iron bridges, next came the evolution of the suspension bridges. So with their ability to span longer distance, became more prominent with the use of iron and steel cables. So after this evolution of this iron and steel, in 20th century, saw the rise of using this concrete and the reinforced concrete structures, leading to the construction of more durable and the cost-effective bridges. So the next is the new type of bridge called as the cable stayed bridges. It offers more aesthetic and it is mainly used for to span longer. It is used for longer span. So coming to the modern era, there are advanced materials and the techniques are used for the construction of bridges. So the modern bridges utilizes the advanced materials like high strength steel and concrete along with the sophisticated engineering techniques and the computer aided design. So coming to the sustainability and the aesthetics of the bridge design increasingly focus on sustainability, long-term durability and aesthetic appeals. So here we can see the evolution of the bridges in 1800 AD. The first cast iron bridges was built, and the next came in 1900. You have this evolution of the truss bridge. In 2000 there comes the evolution of the pre-stressed concrete bridge. Then we have this bridge built with the iron, and later we have this suspension bridge in which steels are used as suspended cables. So as we see, in earlier humans, the historic development of the bridge is a fascinating story of human ingenuity, stretching from the primitive log crossing to the modern mega structures of steel and the concrete. So we have the different types of bridges. The boulders or the stepping stones are also used as simple bridges to cross from one end to the other end. So we have this rope bridges where the fibers are twisted and it is made into strong ropes, and they are tied together and they are capable of tying and holding together the structural elements used to span the deep gorges. So these are the few modern pictures of the few modern bridges. We have the Golden Gate Bridge is a suspension bridge, and we have this Tower Bridge, and we have this viaduct, And we have this Brooklyn Bridge, Sydney Harbour Bridge. So see, these are some of the few bridges, modern construction bridges. I have taken it for reference. So coming to the components of bridges, so the main classification of the here again we can see the detailed breakdown of the bridge structure. So the superstructure consists of the deck, the beam girders, the rails, parapet walls, expansion joints, and the substructure consists of the pier, abutments, wing walls, bearings, and the foundation. So apart from this, we have the other important components such as the approach slab, um, and the handrails and the guardrails and the anchors. So coming to the superstructure, the deck, the surface of the bridge where the traffic moves is called as the deck. So it can be made up of concrete slab or any other material. So the next one is the beams or the girders, the structural members that supports the deck and transfers the weight to the substructure is called as the is your beam or the girder. So the next we have this rails and the parapet walls. So this is mainly provided for the safety barrier along the side of the bridges, preventing the vehicles or the pedestrians from the falling off. So coming to the substructure, we have the piers, abutments and the wing walls. So the piers or the vertical support that stands between the abutments and transfer the load to the superstructure, transfer the load of the superstructure to the foundation. The abutments or the end supports that retains the earth embankment and transfer the load to the foundation. And this wing walls extending from the abutment to retain the earth fill of the approach roadways. So coming to the foundations, we have this pile or the pile caps. So the piles are the deep foundation elements driven into the ground to transfer the load bridges to the stable soil or the rock. So we have this pile cap, the concrete structure that distributes the load from the piers or the abutment into the piles. So the footing, the wide base, we have this footing, it's a wide base that distributed the loads over the larger area of the soil. So these are the few major important components of the bridge structure.